Hey, good morning, all of you. We are discussing about the hybridization concept yesterday. Already we completed that one. So, what is the drawback in the hybridization? The hybridization concept is successfully explain the shapes and bond angles of the molecule when the central atom will not having any lone pairs on it. When it having lone pairs on the central atom in a molecule, the bond angles and shapes are changing. Then hybridization concept is answered. Then one more concept is came Vesper theory. VSEPR theory. What is the full form of Vesper theory? Just write down here. V means valence shell electron, valence shell electron pair, repulsion theory. Valence shell electron pair repulsion theory, nothing but VSEPR, Vesper theory. So how this is successful? What is the postulates of this Vesper theory? I will explain to you. See, the first point is nothing but shapes of molecules. The shapes of molecules depends on a repulsion between pair of electrons around the central atom. So what is the first point? Whatever molecule will be there, the shape of the molecule is depends upon a repulsion between pair of electrons around the central atom in a molecule. So around the central atom you may have lone pair, bond pair and bond pair or lone pair. Whatever we have between them, repulsion will be there. The repulsion will affect the shape and angles in a molecule. Next point I will tell you, listen carefully. You have A atom with lone pair, B atom we have with X bond pair will be there. So now in case of A atom, whatever pair on it is calling as a lone pair. So this lone pair occupies a more space, a more area around the A nucleus. Why? So in this lone pair is affected by single nucleus of A atom. Single nucleus. Because of single nucleus, what happening? Force of attraction between a lone pair and a nucleus is less. Because of less force of attraction, the lone pair is occupying more area. Now you comes to this one, it is calling as bond pair. I said, what is the meaning of bond pair? In this bond pair, in this bond, the pair which is involved is calling as a bond pair. The bond pair occupies a less space. So what is the less space? Why? So this bond pair is attracted by two nucleus, B nucleus and X nucleus, two nucleus. So because of two nucleus, what happening? Force of attraction between the two nucleus will be high. Force of attraction between them will be high. Automatically they are occupying less area, or they are existing in between them, the occupying area will be less. So always lone pair occupies more space and bond pair occupies less space. And you can see one more point according to Vesper theory. You have a atom, around it we have two pairs. So those are calling as lone pairs. Yes, this is the one lone pair, this is the another lone pair, calling as lone pair. Between lone pair is a repulsion is more or less, is a very important thing. In case of lone pair, repulsion will be very high. Why? Those electrons is not stabilized in the bond, that's why between them repulsion will be definitely high. Now I will tell A bonded with B. On A we have a pair, in between AB we have a pair. So on A lone pair, in between means is calling as a bond pair. Now, repulsion between lone pair and bond pair will be more or less than lone pair. Here repulsion will be less. Why? The bond pair is already stabilized with the bond, and this is still not involved in the bond. That's why is a more means in between them relatively repulsion will be less. Now I am taking a atom with X bond and a atom with Y bond. Around the central atom A we have which one? Bond pairs we have. This is the one pairing bond, this is another pairing bond called as bond pair and bond pair. Between bond pair repulsion will be very less. Why? They already involved in the chemical bonding, they already stabilized. That's why lone pair repulsion is more than lone pair than bond pair bond pair. And last point I want to tell, same repulsion in the bond only I want to discuss. Between A and B we have a single bond. Between A and B we have a double bond. Between A and B we have a triple bond. Where repulsion will be more? In case of triple bond. Why? One sigma bond is there and two pi bonds is there. You know pi bond is calling as delocalized electron. They are always continuously revolving above the sigma bonded plane and below the sigma bonded plane. They are lessly attracted with the nucleus. That's why more repulsion. Here only one sigma and one pi, little bit less. Then this is a very less repulsion. Less repulsion means more stable. That's why sigma bond. Single bond is less repulsion than double bond than triple bond. See, once what I want to tell, in case of or according to Vesper theory, always the shape and angles in a molecule is depends upon repulsion between electron pairs around the center atom. Always lone pair occupies more space than the bond pair, because lone pair affected by single nucleus, bond pair is affected by both the nucleus. And always lone pair repulsion will be more than lone pair than bond pair. Out of single bond, double bond and triple bond has more repulsion. All of you getting it? Yes. Just I will tell you some important points what happening over there. See, I will tell you one example is nothing but SO4 2 minus is there. What is the hybridization? I want to know. Yesterday I told one formula for this one. Number of hybrid orbital is equals to, what is the central atom here? Sulfur. Surrounded by how many atoms? 4 oxygen atoms plus off into group number of the sulfur atom 6 and number of bonds around the sulfur. Each oxygen form 2 bonds, 4 oxygen form 8 bonds, and minus 2 charge is there in the formula right on opposite. So then what we are getting? 4 plus 8 minus 8 0. Anyway we want 4 hybrid orbital. 4 hybrid orbital possible in which hybridization? sp3 hybridization. I told already first one is always bond pair, second one is lone pair. No lone pair, the concept is successfully explained by hybridization. But because of lone pair, the deviations is coming, that successfully explained by the Vesper theory. All of you clear? Yes. Now, I will explain Vesper theory. One table will come. Observe very carefully. Especially competitive point of view, this is important topic. Listen carefully. Under Vesper theory, how lone pair and bond pair will affect the bond angle shapes. So first one, nothing but type of the molecule. Type of molecule. And bond pairs and number of lone pairs and shapes of molecules and examples. See, the first category I will tell, but listen carefully. I am taking AB3 molecule. I am taking A is the central atom. Around A we have 3 B atoms. We have single bond. Means how many bonds will be there? 3 bonds is there. 3 bond means 3 pairs is there. That's what 3 bond pairs is there. And we have how many lone pairs? 0 lone pairs. 3 bond pair, 0 lone pair means together 3. 3 means we want which hybridization? sp2 hybridization. I will mention here hybridization also. sp2 hybridization. No lone pair, no problem. Then we are getting which shape you are getting? Trigonal planar shape we are getting. Trigonal planar shape we are getting. Trigonal planar means how can you show this one central atom like a triangle? Like this we are getting. So can you give me example for this one? A BCl3 molecule will be there. And as well as we can take C2H4 and as well as we can take BF3 molecule, and these all will undercomes sp2 without lone pair. Now under AB3 only A, B, 2, E. What is the meaning of this one? A is the central atom, around it we have two bonds, two pairs, and E means lone pair. Two bond pairs and one lone pair. Anyway, together three hybrid orbitals, that's why we want sp2 hybridization only. Okay, now how shape will be changing? Out of three bonds are there in this trigonal planar. Out of three bonds, one bond has to be cut. You cut one bond. After cutting one bond, what shape you are getting? A V shape you are getting. A V shape, also called as bend shape, also called as angular shape. Angular shape can be shown this one as like two bond pairs and one bond pair. Can I give you one example? SO2 molecule and SnCl2 molecule. Stannous chloride. You can apply the formula, you will get it. And under this, I will tell you one more category, and I am taking this is one category. Second category, I am taking AB4 molecule. I am taking AB4 means what? 4 bond pairs and 0 lone pair. Together we want sp3 hybridization. Under sp3 hybridization, we are getting which geometry? Tetrahedral geometry, successfully explained by hybridization because of more lone pairs. What is the geometry expression? Two bonds are lying in the same plane. One bond is coming towards observer, another bond is going away from the observer, denoted by tetrahedral geometry. Can you give me the example for this amount? CH4 molecule. No, under this I am telling the some conditions AB3E. What is the meaning of this one? 3 bond pairs and 1 lone pair. Together 4. Also possible in which hybridization only? sp3 hybridization only. Okay, if 4 are means no lone pair, all are involving the body tetrahedral. But one is a lone pair. One is lone pair means one bond has to be cut and place lone pair. Which bond has to be cut? Cut any one bond. So after that, what happening? Two bonds are lying in the same plane. One is towards us, one is away from us. So now I am cutting this bond. Then which shape is coming? Pyramidal shape is coming. This part we can write it as pyramidal in shape. The pyramidal in shape can be shown as with the lone pair. Can you give me the example for this one? NH3, NF3 and NCl3, these all will undercomes. Yes, apply the formula, you will get 3 bond pairs and 1 lone pair. After that, I will give you one more category, AB2E2 molecule. Means 2 bond pairs and 2 lone pair. Which hybridization is coming? sp3 only. Okay, in tetrahedral geometry, cut one more bond. Means 2 bonds has to be cut. Cut the 2 bonds. This bond you cut it. Then which shape is coming? Bent or angular shape you are getting. V shape or bent shape, or we are getting angular shape you are getting. So can be shown this one as like with 2 lone pairs. After that, what molecules we are getting? H2O we are getting, very good, because of 2 lone pair. And OF2 we are getting oxydichloride, then also oxygen has 2 lone pair. Check it, hybridization formula, you can get it, 2 bond pair, 2 lone pair. And third category, you see carefully, AB5 molecule. AB5 in 5 bond pairs and 0 lone pair. Together 5 hybrid orbital, possible in which hybridization? sp3 dehybridization. sp3 dehybridization means which geometry we are getting? Trigonal planar geometry we are getting. Trigonal planar andre triangle should be coming first. Okay, we have to join these vertices. After that, what we are getting? Above one bond, below one bond is coming.
Already we discussed in the hybridization, best molecule is PCl1. No, it is successfully explained by hybridization because no lone pair. But lone pair is coming hands up hybridization. Then Westphal theory is explaining. What is the concept of this one? AB4E means what amount? 4 bond pairs and 1 lone pair. Hybridization is sp3d only, but shape and angle will be changing. Yes, here concept is very careful. Now, equatorial bonds are making angle is how much? 120 degrees, but axial bonds are making angle is 90 degrees. Now, by cutting which bond, we are getting less repulsion and more stable molecule. If you cut equatorial axial bond cutting at lone pair means this lone pair and bond pair are separated by 90 degrees angle means less angle means more repulsion, should not cut. If you cut equatorial bond, what happening? This making angle with the remaining will be 120 degrees. 120 degrees means more angle means less repulsion. That's why you should cut that equatorial bond. Equatorial bond has to be break. Okay, then I am cutting this bond. Then we are getting which one? Like this left side and above and below. Here lone pair is coming. Can I rearrange this shape? Is nothing but like this central atom, one bond, lone pair. Calling as seesaw. So in playground where children are playing like this up and down, no? So one table is there. That's calling as seesaw shape. So can you give the example for this one? SF4 and SCl4 and SeCl4. This all will undergo same molecule. Apply the formula. Now I am taking one more example among AB3E2 molecule. Means 3 bond pairs and 2 lone pairs. Which hybridization is coming? Same hybridization is coming. Which bond has to be cut equatorially? Okay. Now what I am doing? I am cutting this equatorial bond and this equatorial. Why am I only cutting equatorial bond? Equatorial bonds are making angle is more. That's why repulsion will be less. Then stability will be high. That's why we should cut these 2 bonds. If you cut these 2 bonds, which shape you are getting? Central atom, above bond, below bond, like this. Here lone pair, here also lone pair. Can we rearrange this one? Yes, central atom, left side bond, right side bond, down bond. After that, 2 lone pair. Which shape you are getting? T shape you are getting. T-shaped molecule. So can you give the example for this one? ClF3 and BrF3 we are getting. Calling as this one. And like we can see one more thing is nothing but AB2E3 molecule. What is the meaning of AB2E3? 2 bond pairs and 3 lone pairs. Which hybridization? C. What should do? All equatorial bonds cutting. 1, 2, 3. After that, which shape you are getting? Central atom, above bond, below bond. After that, 3 lone pairs is coming. Is it which molecule? Linear in shape. Linear shaped molecule. Just I will give you one example. XCF2. Apply the formula we are getting hybridization. sp3d, 2 lone pair, 3 bond pairs. And next 4th category, AB6 molecule. AB6. What is the meaning of AB6? 6 bond pairs and 0 lone pair. Which hybridization is coming? sp3d2 hybridization is coming. Then what geometry we are getting? Octahedral geometry we are getting. Octahedral geometry means central atom, bond like this, like this, like this. After the square and after that we are getting above 1 bond, below 1 bond we are getting. Already we land in hybridization because no lone pair, that's why SF6 molecule is the best example. Not like that, I am taking AB5E. We are taking 5 bond pairs and 1 lone pair. Same hybridization is happening sp3d2. Now all bonds are making angle is equal. Then which bond has to be cut? Cut any bond. But if you cut the equatorial bond, axial bonds is having repulsion, equatorial also having repulsion. But if you cut the axial bond, only equatorial bonds are affected. That's why better cut this bond. So then what you are getting? The remaining 4 bonds is as usual like this, below as is like this. So then which shape you are getting? Square pyramidal shape you are getting. Square pyramidal shape you are getting. The square pyramidal shape means, can we give me the example for this one? ClF5 and BrF5 will be the bromine pentafluoride will be there. Apply the formula you are getting. I will tell you one more example. Is nothing but AB4E2 molecule. Means 4 bond pairs and 2 lone pairs. Anyway 6. Possible in which hybridization? sp3d2. What should do? cut one more bond from below. After that we are getting which geometry? Square shape you are getting, okay na? And above one bond, below one bond, one pair is coming. Which shape you are getting? Square planar we are getting, or square shape you are getting? Square planar shape you are getting. So can I give the example for this one? Xenon tetrafluoride XeF4 is the best example for this one. Okay, just I will tell you, a last category is nothing but fifth one, AB7 molecule. AB7 means 3 bond pairs and leave 0 lone pair. Which hybridization is happening? sp3d3 hybridization. Then we are getting which one? Pentagonal bipyramidal shape you are getting. What is the meaning of pentagonal bipyramidal? 5 bonds are lying in the same plane like a pentagonal shape. After that above one bond is coming, below one bond is coming. Okay, best example for this one, IF7. But equatorial bonds are making angle is 72 degrees, axial bonds are making angle is 90 degrees. Now I will take one more example under this one, AB6E. Means 6 bond pairs and 1 lone pair, AB sp3d3 hybridization. Then what bond has to be cut? We have to cut the axial bonds only. We have to cut axial bonds has to be cut. Why axial bond has to be break? Axial bonds are making angle of much more 90 degrees. More angle means less repulsion. Less repulsion means more stable. But if you cut equatorial, making angle is less, then lower pair bond pair repulsion will be very high because less bond angle, more repulsion, unstable. That's why we should cut axial bond. Again, you can cut above the bond or below the bond. Then we are getting which one? Yes, 5 bonds is as usual in the same plane like a pentagonal ring. And after that we are getting below one bond, above bond place is lone pair. Anyway, today the central atom we are getting how many bonds? 6 bonds we are getting. 6 bonds having molecule is actually calling as octahedral geometry. But is it perfect octahedral? No. That's why it's calling as distorted. Distorted means what? Disturbed octahedral is nothing but XeF6 best example. I will tell you one example for this one. If you take XeF2 molecule, all of you getting one? Based on this one, I will tell you how you will ask a question. What are the shape? What are the lone pair, bond pair in XeF2? Xenon is the central atom. Around it how many atoms? 2 plus off into group number of xenon in 8 minus each fluorine 1 bond, 2 fluorine 2 bonds. 2 plus 8 minus 2 6 by 2 3. So we want 5 hybrid orbital. Possible in which one? sp3d. First one is the bond pair. Second one is the lone pair. So actually 5 hybrid orbital, trigonal bipyramidal, but we are removing 3 bonds with the lone pair, then linear shape is coming. That's why XeF3 molecule is like this, XeF. After that we have 3 pairs on xenon, linear shape. Now I will take second example, XeF4. This is important for the competitive. Central atom is xenon. Around it we have 4 atoms plus off into xenon 8 minus 4 fluorines, 4 bonds. We are getting 4 minus 4 by 2. Nothing but 4 plus 2. 4 plus 2 means same. sp3d2 hybridization. First one is the bond pair. Second one is the lone pair. sp3d2 means actually octahedral geometry, but cut 2 bonds, then we are getting square shape. XeF, like this we are getting 4 bonds. Okay na? After that we have lone pair above and below. Third one, we have to take XeF6. Tell me. So xenon is the central atom. 6 plus off into xenon 8 minus 6. Nothing but 6. 8 minus 6 2 by 2 1. 6 plus 1 this one 7. 7 hybrid orbital possible in sp3d3 hybridization. Then all our bonds are no 6 are bonds, 1 is lone pair. That's why should cut this bond and we are getting this shape now. It's calling as distorted octahedral. So practice 2-3 times is a very important for competitive point of view. All of you understood? Yes. See, the one more small concept. Already we discussed about the ionic bond and covalent bond and properties and everything. Now we are discussing about the coordinate covalent bond. See, the very important chemical bond, coordinate covalent bond. This coordinate covalent bond has different names called as dative bond, and also called as donor acceptor bond. Okay, I will explain what is the meaning of coordinate covalent bond. So first of all, we have to discuss something regarding covalent bond first of all. Then we will go for coordinate covalent bond. Anyway, covalent bond formed between a non-metal atom by sharing a directional bond denoted by single line, one pair, two pair means double bond, three pair sharing means triple bond. Before that, I am taking two atoms A and B. A has single electron, B also has single electron. Right now both are unstable. How they are becoming stabilized? By sharing. So this A atom contributes one electron, B atom also contributes one electron. After that, between AB we have a pair. The pair is involving in the sharing. After sharing we are getting a single bond, we are getting that only we are calling as covalent bond. So did you observe here the shared pair is coming from both the atom, then the after sharing getting bond is calling as covalent bond. Covalent bond is a chemical bond which is formed by a sharing of pair of electrons which are coming from both the atoms. Now we are discussing about the coordinate covalent bond. Yes, a small variation. Listen carefully. You have a atom and B atom or a particle. A already having one lone pair. This is some condition should be there. A is already stable because of is having an octet obeying rule. After that, it should be having lone pairs of electrons on it. At least one lone pair requires. I am showing for my convenience beside it. Okay, we have two species. One species is already stable and obeying octet rule, means around it 8 electrons is there and also has a lone pair of electrons on it. And what about the B atom? Right now it is unstable. B is right now unstable because incomplete octet rule. And for octet rule it has shortage of a pair of electrons. Means after receiving two more electrons becoming stabilized. Means it has a shortage, means vacancy for attainment of the octet rule or stability. Now what happening? This is already stable and has lone pair, and this is not stable because of two more electron shortage is there. Then what happening? They will comes to understanding and both electron is contributed by A atom only. After that, what happening? Between A and B, a pair is involving in the shape. But observed or no, this pair is not coming from both the atom, from any one of the atom, and which is donating that pair is calling as donor atom, and which is receiving them is calling as acceptor atom. Okay, sharing and everything is will be over. After that, how can we show this one? Between A and B, we can show the coordinate covalent bond with the arrow mark. Always, normally covalent bond is denoted by single line, but this is denoted by arrow mark. Arrow mark indicates always towards acceptor side. So A donating electrons to the B atom, always head of the arrow mark towards acceptor side. That's why this is only calling as coordinate covalent bond is always directional bond, a strong directional nature or a directional bond it is. Did you got my point or not? Just you see, coordinate covalent bond means is a covalent bond which is formed by sharing of pair of electrons which are contributed by any one of the bonded atom only. But here share is coming from both the bonded